the next use case will be how exactly do we validate our test cases. So how exactly do we validate our transformations? So there are two basic trains of thought here. There's white box testing and there's black box testing. So white box testing principles involve the end user defining a certain transformation, and the QA tester now has to validate the transformation by replicating the logic of the transformation. In base words, if the end user has actually done the data set, and this is example, we can take that geography key was the column which was affected, and this is the data set that has already been updated. Here the development change has been done. You as a QA tester need to pick up the source file. This is where you pick up the raw source file and you apply the logic, but you do not copy the code, as testing always has to be independent. You apply the logic from scratch here. Here I've defined him as a parameter of custom functions. I can use my OpenAI assistant to help me with this as well. And once I've done this, I can actually compare them once again. And here I see in the comparison, most of them are a pure match, and the mismatches are all limited to geography key, which is expected. And in this case, we see that there's a set pattern here between 18 and 20. And what this reflects is that the logic for 18 versus 20 is something that has not been coded correctly, either by me, the QA tester, or developer. Or it could also be a mapping error between the two environments. So one way or the other, I've isolated and found out a specific potential issue in the logic transformation of this particular use case. Moving on, we understand that this is not something that every specific that can be done for every specific transformation, as replication takes its own time. So in this case, we can do black box testing as well. Black box testing here, as the name suggests, implies that you as a QA tester, you're not entirely aware of the exact transformation logic here. So here I've defined transformation logic as just a parameter, but you're aware of the outbound limits that are needed on this transformation. An easy example here would be if you're working with multiple tables, you do know that at the end of the day, the particular transform data set should not have duplicates on certain columns, or its particular metrics should not be out of range or out of bounds for a particular set of limits. It could also be along other lines. It could be with regards to business rules. For here, we actually bring in data quality rules. A source data set is brought in, and the columns are defined as is, and then you are given a zero code or low code system where you can actually just define what type of rule you would like to deploy. I'll use a duplicate rule for the easiest showcase, where I define the duplicacy rule, define alongside which columns I want to define my duplicates, and that's it. I'm done. I can change my success criteria to allow a fewer percentage of duplicates or number of duplicates, so as to not trigger or alarm the test case by changing the success criteria. And of course, I can also add a where condition or other conditions to make sure that this test case only runs for specific records. But I'm already done. This particular rule can be parameterized easily using global and local parameters, and this rule set can be exported and imported as well. The wizard that we saw earlier for data compare, the same can be applied for these set of rules as well. And here I've already created a few set of rules, so we'll quickly go through those. First one is, of course, a basic null check. Our primary key is customer key, and we do want to ensure that that this particular key is not null. And here you will notice that we are using the attribute rule. The attribute rule is one of our most powerful rule templates, because it takes into account the data type of the column you're working with. So in this case, email address is a string, and correspondingly changes the operators in accordance. So here we see, because the data type here is string, contains is number, is not a number, regular expression, pattern expressions, and other such formats come into the picture. And again, this is only because this corresponding data type is a string, and I've used this to ensure that email address contains adventureworks.com. On the other side of the spectrum, we have birth date, which is of course a date column, and as you see, the operators here are is before, is after, and is between, and so on. And so I have basically defined two sets of business rule requirements as basic rule templates that can be easily exported through other systems as well. Finally, if I'm working with something that's a bit more complex that I do not want to work across, I can of course define a SQL query or expression rule. This is very easy if you want to import your existing rules as well. But going back to attribute rule for a second, if I want to define something specific and niche and I want to reuse it, this set of operators here, these can be user defined as well. So you can just define the exact conditions you would like to apply. A developer can go in and define them, and the end user only has to choose the corresponding operator right there. To round out, we do have a few more test cases that we couldn't cover in this particular demo. This is with regards to domain checks, which basically ensures that the data in a column is within the list of expected values, and of course metric value checks. This is where you want to validate your aggregates. Easy example here would be if you want to make sure that the sales figures from two distinct data sets. Imagine you're a manager and you get your weekly sales figures from your team in an Excel, and you get the same from your CRM tool. You would like to ensure that the final aggregate of the total number of sales or total revenue per week is within a certain bound, so that it's not too off from what you're seeing within your system. So in this case, you would run a metric compare across the two tables. Other examples would be ensuring that the mean or total or max values do not exceed or are below certain expected ranges, and that's single metric value. Of course, here I've applied this to a transformation, but as you might notice, you can apply this to raw files as well, and that is something that we can cover in data quality monitoring. Of course, before that, we want to have a quick showcase and shout out to other use cases as well, where as you see, we have a plethora of use cases, but I want to quickly jump and showcase metadata compare. It's very similar to what we saw when we were creating our migration validation wizard. Here, you're basically prompted to define the different sources of your system, and then objects are dragged and dropped within systems. This is a curated example, but of course, I can drag and drop objects in this as well. And the results in this case, instead of going to the actual data, actually tries to match the metadata. So here we see the columns which are present in one, not the other, data type mismatches, and even something as simple as a column length mismatch, which is very crucial for columns such as address lines and demographics. So in this particular fashion, we also perform metadata comparison. Next, what we would like to get into is actually showcasing observability and how exactly it works. So let me just ensure we are Next, we would like to showcase data observability and how exactly it works. So here I've taken a raw file and I want to ensure that I profile this file and I catch anomalies within this file as well. So here it's a CSV file, but once again, the application is pretty agnostic to the data set to the sources of the data set. So this could be a JDBC connection, it could be a report, it could be an API connection as well. Here we've just made sure it's a basic file, and this particular file is loaded after applying a transformation every week or every day. And now, how do we do profiling? Well, the profile node is pretty straightforward for the end user to use because it allows the user to define multiple aggregates across multiple columns. Each of this aggregate count and pattern and frequency analysis is done on every run. So at certain points, if say there's a volume drop within the data, or you've seen the distinct counts have increased, or the distribution has altered, or the patterns that you see within the data sets have changed, the application can catch that. Here in the results, as you can see, we have found a few anomalies within the system, and if I can just go in deeper into yearly income for now, I'll see a much more detailed look using mean. And here I see that yes, while the mean was trying to stabilize itself over the past few runs, it has suddenly had a spike. This implies that something is off within my data set. Mean is just an easiest example to pick up. The other good examples could be with regards to volume, with null counts, distinct counts, and other aspects as well. The other things, of course, are with regards to the patterns. This is crucial when you're working with date patterns, or if you're working with licenses or other expected pattern sets, where things such as primary keys, license plates, or other government IDs that you might expect a set pattern in. But if you see something out of the application or out of the batch or out of trend, the application can directly catch that. And finally, we do have the frequency analysis to match distribution count.